Hey guys, welcome back to .NET Conf. I'm Jason, this is Adrian.
Hello.
We're with you for yet another .NET Conf session. This one is really kind of neat. IoT with Xamarin, that's Internet of Things with Xamarin. We're gonna have a lot of fun with all of these devices that you may see, depending on where the cameras are aiming at right now. I'm not sure, but we're gonna have a lot of fun with a lot of this stuff. Gonna be super cool. We've got some craziness going on back here this time. So by the way, before we get into our Internet of Things, how about we tell you a little bit about ourselves?
Absolutely. So my name is Adrian Stevens, and I'm with Internet of Things University. Wait, that's not right. Xamarin University. But as we see, that's going to work very well with IoT. But yes, I'm on the curriculum team. I work with the really fantastic people that write the course materials, the classes that get taught at Xamarin University, taught by the absolutely fantastic instructing staff, the team we have.
Speaking of the instructing staff, I'm one of them. I'm not sure if I'm one of the fantastic ones, but I'm there. I'm teaching classes every day. And it's a lot like what we're going to do today. We have a lot of fun. We look at how to build mobile applications, how to build Azure applications. We teach you everything you need to know to become an outstanding developer. You're probably already outstanding developers, but maybe you're not mobile outstanding developers or Azure outstanding developers. That's where I come in. So we help you guys get up to speed on those technologies. Interactive classes, small classes, 20 to 30 people, where we actually get to interact, talk together, solve problems together. A really great experience.
Absolutely. Xamarin University has a ton of free content as well.
Exactly.
You can learn things like cross-platform mobile development, learn how to do code sharing across not just phones and tablets, but even things like IoT devices as well. We learn those techniques we can apply to sharing C# and .NET code. Again, you mentioned a lot of things, Azure, testing, all kinds of great stuff. Lots of free content, tons of instructor-led courses.
Over 80 at this point, I think, or very near 80.
Getting close,
if it's not over. A lot of stuff.
So yeah, definitely a place to go if you want to learn more about Xamarin and cross-platform mobile development. Please head over to university.xamarin.com.
So now, let's
get into it.
IoT. This is so good.
So yeah, as Jason mentioned, it's all about IoT here, and this is really cool because it's a little bit. Well, it's cutting edge. I mean, we know IoT is pretty new.
Right. I mean, we've certainly had some of these devices around a while, but it's really becoming a lot more accessible. We're especially seeing things like the machine learning on the edge stuff happening. So we're able to have these trained machine learning models running right on the edge, meaning right on the little devices that are deployed to like your tractor in the field, so that your tractor is making intelligent decisions about how to plow the field. Really impressive stuff happening because of devices like these.
Absolutely. So let's get into it. But we're looking at deploying IoT solutions to a couple of different platforms.
Yeah, we have there's actually a lot lot of platforms out there. We'll end up focusing on a few.
So on a few, and we'll talk about code sharing techniques and also really how to leverage Xamarin with this. It's really cool.
Exactly, really cool stuff. Even Xamarin Forms on this IoT stuff. Even Xamarin Forms.
You get to show off a little later.
Yeah, it's going to be kind of fun.
So before we start, let's just maybe give a bit of a shape to IoT. I know there's a lot of definitions out there.
What do we mean by Internet of Things?
And so, we think of, I think first and foremost, it's devices that are capable of, interacting with the real world, interacting with the physical world.
Right, and that might be detecting the physical world, like we're doing today. When I move this thing, we detect movement and gyroscopic motion. Might be temperature, but it might also be influencing. Turning that tractor, driving that tractor.
Absolutely. Oh, of course. I mean, we see all kinds of fun things. There's lots of commercial applications. Temperature's a good one, but not just reading temperature, but responding, adjusting the thermostat based on that.
Turning off equipment, rather, if it gets too hot. Make sure it doesn't overheat and damage that equipment.
Absolutely. Then, of course, the other part of IoT, of course, is the I, is the internet.
The internet.
And so I'd say that, IoT is the devices have some way of connecting to the internet. Now, often that's on the devices themselves. We see some good examples. There's a Raspberry Pi here hidden behind this ribbon cable, and it has Wi-Fi built into it. But these devices might also talk through a gateway, but that gateway is what's connecting to the cloud. Probably something like Azure.
Absolutely. We'll see maybe just a little bit about talking to Azure with devices in another .NET Conf session today.
Absolutely. We're going to have a lot of fun with that one as well. But let's talk more IoT. So
let's.
So if you're new to IoT, or you've just come across it and you're like, oh, this looks confusing. It's a new development paradigm. It's a whole new skill set, and there is a lot to learn. But there's also a lot of commonality to mobile development as well.
There is, yeah. When we look at this device right here, this is very similar in a lot of ways to a mobile platform. This device right here has sensors in it of its own. It's got a processor. It's got networking capabilities. Now, not all of our IoT boards have that much functionality.
But it seems to be, it's a bit of how the direction's going as well. We're seeing definitely a ramp up of processing power.
Exactly, absolutely. And so there's a lot of commonality here. Now, sometimes we have very small displays like on a mobile phone. Sometimes with these we have no displays whatsoever, so there are obviously some differences. But this runs software. This has software that can respond to things that are happening over these wires, and it can send information down those wires to, again, influence the real world. Software that you write, Xamarin software hopefully, influences the real world that way.
All right, absolutely. Again, it's just another software platform. Of course, there's some engineering around it, but at the end of the day, we're writing applications that are running on the platform. And again, hopefully send that data up to the cloud as well. So let's talk a little bit about those IoT platforms. And I'm going to own it right at the start. There's a lot of IoT platforms, a lot of different hardware solutions, a lot of different software solutions. I'm not going to try and guess at the full breadth of available devices, but we are seeing a few major players, at least in terms of operating systems.
Yeah, and a lot of the platforms that are out there are kind of married to their own hardware, and they're not necessarily built to have a scale from going from hobbyist or prototype up to production. A lot of the platforms are right there already in industry, and that's kind of just where they're at. And we don't want to focus on that today. We want to focus on the platforms that give us the option to prototype, to play around a little bit, and then have a path to production, a path to actually getting things manufactured and built. And so those platforms, well, seem to be Android Things is up and coming.
Yeah, it's a new platform, but it's definitely it's exciting. It has a lot of potential.
It's obviously backed by a rather big player in the world, so we expect good things from that, even though right now it's pre-release. Windows IoT is completely released, is running hardware out there in the real world.
And of course, Microsoft has had a long history of IoT and embedded devices through many OSs, and this is really just the latest iteration of that.
Exactly, and the same can probably be said of Linux. It's been running on embedded devices for a really long time, and we can actually approach Linux through our Xamarin environments, through, for instance, Mono as well.
So pretty fantastic. So 3 platforms that we love writing software for.
Right, a lot of options.
Yeah. So we're going to focus on 2 of them today. And what's really exciting about the 2 platforms is we can actually write C# code. No big surprises here. We're going to leverage C# and .NET. We can write C#, have that code execute on these platforms, but it's also possible to share code across these platforms as well.
Yeah,
just like we love and do in Xamarin.
Yeah, and it may be a little surprising, but there are definitely opportunities to run similar hardware on different platforms and want to share that code. In fact, this setup that you see right here, we could run either Windows IoT or Android Things on this exact setup, and we'd only have just a very tiny bit of platform-specific code that we'd need to interact with. The rest of that's going to be shared code, going to be shared Xamarin code to have exactly the same solution running on the Android Things operating system or the Windows IoT operating system.
Fantastic. And I see a question come in, and I think it's a well-timed question. How much do I need to know about electronics to do IoT? And of course, it's like many disciplines where, depending on the complexity of your solution, it's going to depend on the level of skill and knowledge you need. But the great thing about IoT these days is it's really accessible. There's a lot of great starter kits. We see devices like this. I'm jumping ahead a little bit, but you see there's some hardware here on Jason's Raspberry Pi that makes this easier. We've got prototyping boards that makes it very easy. We're not doing much soldering here.
Yeah, we didn't have to solder this sensor. So by the way, this entire setup that we've got here is one sensor and one Raspberry Pi, which is really the computer, the thing that's going to run Android or UWP. This is a sensor. The rest of all this setup is actually literally just there, as Adrian said, to help me make it easier to wire that chip. So you can see these wires plug in there and then go to this thing that has a nice set of labels on it, because my Raspberry Pi doesn't actually have labels on the pins. Has this nice set of labels, and then all of this just makes it easy to plug this thing into this thing's input-output pins.
Yeah, and I think what I want to say for the software side is to do IoT development as a software developer, accessing the interaction points, so the I/O, the GPIO on these devices, or the serial buses, it's just software. It's just C#, and so that doesn't require a lot of electronics knowledge. It's the other side of it. It's the physical side where you want to start to learn those things. And the best thing to do is to go onto your platform of choice. And these are two great platforms. There's tons of really great samples that will walk you through the basics and get you started.
Yeah, I think, to be perfectly honest, I think the answer is some. Some electronics knowledge is required. I'm not going to say none. That's absolutely just not true. No. We want to make sure that we don't put 5 volts into a 3 volt input. We have a risk of frying boards if we do that. So we want to be reading the specifications and making sure we get that stuff correct. And there's going to be a little bit of lower level programming unless you find some open source solution for that exact board, which actually we did. So we didn't even write a lot of it. We actually tweaked it, but we just tweaked some of the timings and stuff. But we actually found some open source solutions for some of this as well that we were able to use as a jumping off point. And so if you don't find that, there's going to be, and we're going to look at it later, a little bit of the low level code can be, a little bit painful. It's going to be the type of code that maybe you'll spend a couple weeks writing a few lines of, or a couple days.
But the great news is we're actually going to show you first a really simple example. Literally requires a resistor and an LED, and then we'll go something a little more complicated. But even again here, the actual wiring engineering is minimal. And again, it's just building the bigger solutions where you're going to want to have more complex, more in-depth
Right, and
knowledge.
actually let me revisit something I said too, because even looking at this board where I'm talking about there being some low-level communication. It's true, there is, but once I have that wrapped and abstracted, I've got some low-level events, some events actually that are now C# events, actually just communicating that up to the rest of my C# code. So once that's handled once, and really once just for that board, for that piece of hardware. So once for that piece of hardware, regardless of what I want to do with it, that's handled once. That low-level information is wrapped and C#etized. And now everything else I do, no matter how many applications I can come up with for an accelerometer and a gyroscope, that's done. I'm laughing the rest of the way, writing C# code and nothing but normal, regular, boring C# code. Even the complex code is C# code, but we're messing around with bit shifts and arrays of bytes and stuff.
Fantastic. Should we get into some specifics?
Yeah, let's actually look at some code.
But great question. Thank you very much. We're going to start with Android things. And we're going to start with a simple example here, and let's take a look at Android Things. This is it's a new platform. It's in preview, and really Android Things it's Google's answer to IoT. Now, Android's been floating around. It's been run on a lot of different platforms in various forms, where this is now Google's official IoT platform.
Yeah, we've seen Android be installed on a lot of things other than just phones and tablets over the years. But there were a lot of hacks required to for instance, use the input-output pins and things like that. Well, Google's now made it official that they're supporting and helping out and all that.
Yeah, and I think what's exciting about this is that we've got standardized hardware and we've got standardized APIs. So as you said, some hacks to do the communication with the real world. Well, now Google's formalizing that process. We have a standard API surface. So excellent platform to use, and of course, we as Xamarin love to use Google platforms along with Windows and
right.
iOS.
We of course have Xamarin Android, which means we can always address our Android platforms with C#.
So let's talk a little bit about the devices. So again, it's in preview, and we expect this list to grow. But currently, Google has I guess certified or has put forward kits for a certain selection of hardware. We see there's 3 or 4 boards from NXP. Now the one that's very common for a lot of hobby developers, people get started, is the Raspberry Pi 3.
That's the one we have right here, with the ribbon.
And keep in mind, this is the Pi 3 only. Unlike like Windows UWP, for example, supports the Pi 2. You will need a Pi 3 for IoT. And we also have a couple Intel platforms. Now, these are a bit of a funny one. We love all hardware, and we don't like to recommend one over the other. And I'll admit, I've been a fan of some of these hardware platforms for a while. Unfortunately, however, Intel doesn't look like they're supporting them going forward. So our recommendation here is if you already have an Intel Edison or a Joule, hey, fire it up. But if you're going to buy a new platform, buy new hardware for this, other options, I think.
Yeah, great point.
Perfect. So let's head over and take a closer look at how Android runs on Android Things, because the OS it's a little bit different, but it's very familiar.
Right. Yeah. There's definitely some differences, but we still have that Android kernel, which is kind of a forked Linux kernel. We don't usually call Android a Linux distro because even though it was originally forked off of that kernel, all of the services, all of the high-level services are so vastly different. But so we have the Android kernel. And then, sitting on top of that, we have, of course, all of the, high-level services as well as the Java runtimes that we use and things like that. Now, sitting then on top of that is all the frameworks that we use, the Android SDK, right? The things that have buttons and management for our GPS interfaces and things like that.
So really our API surface.
Right, our API surface, exactly. Now, some of that in Android things is a little different. It's almost entirely the same.
Yeah, it's pretty darn close. There's been a few changes.
Go for it.
Yeah, absolutely. So I think the biggest thing is, IoT devices, as Jason mentioned earlier, will often have displays, but maybe just often or more often, they won't have displays. They're known as headless devices.
That's right.
And so Android Things has been massaged to work on headless devices as well. And so that means some of the UI elements have been taken away. And so we don't have the notification bar, the drop-down notification on Android.
Right, yeah.
So that's been removed.
The window shade thing.
Thank you, yes. I apologize, that term was incorrect. But it's been removed. And so along with that, we don't have a way to prompt the user to grant permissions for your application. And so one of the biggest changes on Android Things is if you request permissions, they're just granted at runtime. You don't have to have the user acknowledge and say give you access to GPS.
Yeah, there may be some richer handling of that when Android Things actually becomes released. But right now, there's no clear path towards getting user input. And so that's why for right now, they've just left it out and said, all right, you get what you ask for.
Yeah. So and that's really probably the biggest change. Otherwise, really, it's a very similar API surface. So you can use a lot of the same techniques, code that you've run on mobile. Now, of course, there is some additions, though.
Of course. Things that make it easier. That's why it's Android Things, not just Android.
Exactly, right? Working with the real world, we have the peripheral I/O. So that's to access the general purpose I/O pins, which is actually primarily what those ribbon cables have to take care of on the Raspberry Pi.
Input, output, those things that interact with sensors, that interact with servos, that interact with motors and things, the real world, as Adrian says.
But there's also some APIs for those standard communication buses as well. So we've got I2C, SPI, et cetera. So the standard things we're seeing in IoT, well, we've got an API surface that in Android Things. So that's pretty exciting. Again, that lets us talk to our sensors and our motors and all those kind of great things. So I want to get into this, but let's quickly just think about our API surface there. So, of course, we're Xamarin developers. We like C# and like our .NET. And so we know that if we have an Android platform, we can use Xamarin Android to bind those APIs and give us a C# binding, lightweight C# wrapper over that API surface, and we can write Android applications in C#.
Exactly.
But Jason, we have that extra API now with the Things library.
They've added a new API, this Things API, and so that's not part of Xamarin Android.
Right, of course. So Xamarin Android is written for really traditional kind of mobile Android.
Right. So if we want to access those new APIs in Android Things, somebody hopefully is going to solve that problem.
And who is it going to be?
Maybe Xamarin should solve that problem.
I think Xamarin's a good person to solve that problem.
By providing us a NuGet package that we can just install.
Yeah.
And then now we can access those APIs.
Absolutely. So we've got an extra package, gets to the API surface, and that is the Xamarin Android Things NuGet package. Now notice here, we mentioned this a couple times, it's in preview, and notice our versioning, we're at 0.5.1. Wonder why we're on that version.
And it turns out that because Android Things itself is in preview. So we're actually in lockstep with them. So as they move forward closer to release, so will our wrappers.
Fantastic. Yeah, so exactly. Expect updates as Android Things matures. But currently, it's a pretty great platform.
It is.
It's pretty robust
already.
already.
Able to have a lot of fun with it.
So we're going to show you some code, quickly get you started. And for those of you that are feeling a little bit intimidated by IoT, this one's a great one, nice simple one to get you going with. But what do you need for this? Well, of course, you'll need some compatible hardware. We saw that earlier. And then for your development environment, well, we need Visual Studio. Now, can that be on both Windows and Mac?
Yes, absolutely. Yeah,
absolutely,
sure.
Yeah. Absolutely, you can. And then, of course, you need the same things you need for Xamarin Android. So you have the Android SDK, and then, of course, Xamarin Android, which gets pulled down with Visual Studio.
Exactly.
So it's a good chance you're developing Xamarin, you're all set. And then, of course, you'll just bring that NuGet package into your Android Things project. And for those of you wondering about the complexity of our build here, nice and simple. Here I am actually using one of those older Edison devices, but it's a great one because I can deploy directly over USB, and it's a headless example, which I like as well.
Very nice.
And we're going to interact with the GPIO, and we're gonna flash an LED. This is our Hello World IoT stuff.
Yeah, and it's pretty cool.
But we're doing C# IoT.
I know.
On Android Things.
Love it.
I still love it.
Let me see it.
Let's jump into it. I'm going to open up my solution here, and it should be ready. So first things first, how do I start? I've got a project. How am I going to do this? Turns out there aren't any templates included in Xamarin for Xamarin for Android things, but we can use our standard projects. So I'm going to file new project. Of course, I got my Xamarin tools installed.
Perfect.
Visual C#, and then let's go down to Android. And I'm just going to make a blank app.
Regular Android app, right?
Yeah. File new, okay, and off we go. So I'm going to jump back to my existing project, but of course you just give it a name and just make an Android application, a Xamarin Android application like you normally would.
Okay, great.
No changes there. Now, we mentioned our devices could have a display. My hardware currently doesn't have a display connected to it. It actually doesn't have display output without additional hardware.
Yeah, I'm consuming the only display we actually have available.
Oh, and sorry, yes, it's
Hello.
excellent. As long as it's visible, I apologize if it's not, but I've got an Intel Edison device here. We're just getting some fine tuning on our display here.
All right.
But for our Android things, projects, we're still going to have an activity because, of course, that's how we start.
Right.
Our
Even
Android
though we
applications.
think about it as being part of Android's UI framework, it's also sort of Android treats them as kind of little mini activities or mini applications, and the activity therefore is kind of required for an Android lifecycle.
Absolutely. So without getting into the full system of Android development, Android apps really built up a lot of components, and an activity is one of those components. And Android things expect you to have a main activity, regardless of whether you're putting up a UI. So we'll have a main activity. And the reason for that is because we actually add some intent filters, and the OS will launch this activity by default if we want this to be the default installed app. And what that means is that the OS will launch this app by default. Because of course on IoT, we're not worried about having a multitasking environment. They're generally single purpose.
And we don't even have a way to have a user launch it. So
for our simple boards, I'm not going to have a mouse and keyboard. I just expect it to run. And so we use these intent filters to kick off that activity.
Exactly. So those attributes that you see that he's got there, what those are going to do is tell the operating system that as soon as this device is powered on, that's the app I want running.
Yeah, absolutely. And you can see here, I love this Xamarin form makes it really easy, or Xamarin Android, I should say, it makes it really easy to add intent filters to our Android application. Just a couple of lines, and again, there's some samples being built already for Android things with Xamarin. So don't worry about frantically writing this down. You can check out our GitHub repo to copy these over. So now let's take a look at some of the APIs. So actually, I should pull back and just show you that I do have the NuGet package installed. This is go to manage.
Have we seen the LED light up yet?
No, not yet. That's my big finale here.
Right. I'm excited. I want to see it.
We'll get there pretty quickly. So just to show you here on my, I've got the Android things package installed. Now, I should also mention that Android things is the newest version of Android. It's great. If you're actually going to, if you're going to set up a device, you're going to flash Android onto your device or onto an SD card. And so, of course, Google is pushing out the latest versions of Android. So I believe my Edison here is running Android 7, but if you're running on a Raspberry Pi with the latest version, you'll be running Android 8. So it's a chance to play with the cutting-edge versions of Android as well. A lot of fun. Let's go back to our main activity. I'll get moving here because I want to give Jason some time for his amazing stuff here as well.
Got some fun stuff.
So here I've brought in the namespace I need. So using Android things, PIO, and PIO stands for peripheral I/O, and that's how we're going to access, our external pins, our GPIO, our buses, and such. So in onCreate here, I'm going to new up a peripheral manager service, and again, this is a very Android-like pattern. I'm going to store off that reference, and then here's a little bit of code. I'm just iterating over. This is a way for me to check and see what devices I have access to on this particular piece of hardware. But what I want to do is I want to toggle one of my GPIOs. I'm going to send a high-low signal through a GPIO so I can literally turn a light off and on. And so here I'm going to open a pin. I open up the pin defined here, and I find it as IO13. That's specific to the Intel Edison. If you're using a different hardware platform, it's great documentation by Android things. So you can head over there if you're using the Raspberry Pi, for example. That'll be a different definition. And here we go. And this is actually gets stored in a type of GPIO. So again, we're seeing our IoT types here being brought in by that NuGet package. And then the rest of this is pretty basic. I'm going to set either the pins to high or low. Usually that means either ground or the voltage for that device. I believe the Edison is 5 volts, if I understand correctly. I think the Pi runs 3.3 typically.
It does.
Yeah. And so I can set the pin either to be ground, 0, or 5 volts. And so I just set it to high. I fire up a timer, and I'm just going to toggle that up and down. Just that simple. But we've got a Xamarin Android project. We're doing IoT.
Cool.
Let's run it. And we're going to see here. And so I'm going to give you a little secret while it's deploying. If you use...
Might have to bring your LED up here.
Yeah, I mean, I'll pick it up and show you
what we have an angle on.
So some of these boards will have a default LED built onto the platform as well. And it turns out that if you toggle GPIO 13 on this board, it will flash the onboard LED as well as toggle the voltage on the output pin. So you may be able to see there's a little LED flashing on the board. And then, of course, we've got a red LED. A simple demo, very much hello world. But again, we're using Xamarin,
we're interacting with the real world
IoT.
Now. Yeah, we're interacting with the real world. That makes it fun.
And I'm happy every time that little light comes on. So,
yeah.
Okay, we've got lots more cool things to show you. So let's get back to it. All right, so let's go to another platform now.
Yeah, how about Windows? Let's talk Windows. So Universal Windows Platform, it kind of says it right in the name, right? It's universal, and it's meant from the ground up to support IoT, so your refrigerators or your Raspberry Pi and your Edisons. It's built to support HoloLens, so I can run my UWP applications on HoloLens or Xbox or on mobile or on desktop, of course. So it's built from the ground up to allow me to target UWP and then play around with what platforms I'm actually going to code to. And so each platform does have some intricacies of their own or some specific things I can target, but mostly I just create a new UWP project. And so what we've actually got going on here is we can see that the Raspberry Pi, as you see on the slide here, is Raspberry Pi is one of the exciting things we can target. There's actually several platforms that we can target. So you can see a Minnow board, Qualcomm has some boards, there's the Raspberry Pi, and then of course, once again,
our Intel.
Sad to see Intel leave the party, but Intel is choosing to leave the party of board manufacturers.
So interesting here. I just want to point out for the Raspberry Pi, we can use both Pi 2 and the Pi 3.
Great point.
For Windows 10, for UWP IoT, and for the Intel platform, it's actually only the Dual. I don't believe the Edison supported it currently. So again, just some things to keep in mind. Obviously, we don't recommend one platform or the other, but you can see there is one commonality that might be a good one to play on multiple platforms.
Right, so obviously the Raspberry Pi allows us to play with all of those platforms, so that obviously makes it a fun choice.
Yeah. But I expect to see more support on both platforms in the future.
Absolutely, absolutely. And of course, regardless of what platform you choose, what physical platform you choose, I know you guys can't quite see this device, but you can at least see my, my fun breakout board here. So regardless of what platform we choose, what physical platform or OS platform we choose, in all cases, we're going to be able to interact with these different devices, these sensors, these servos, these motors, because these all have some pretty common things about them. They either have some very basic digital interfaces or they have analog interfaces. And so that very, very simple commonality means no matter the platforms we choose, we can interact with these things. So if I like Android things, if I like UWP, then I can use those to attack these platforms and to make really cool stuff happen in C#.
Yeah, and I think you make a really good point here with the hardware that it's becoming very standardized, right? Not just the protocols, but the hardware itself. And we mentioned different voltages, but still a lot of things are voltage tolerant, and we can use similar hardware on the same devices. So your accelerometer here, for example, I could connect to my Android Things platform.
Exactly, exactly. And so we've got a little demo here today that I want to show you. This is a universal Windows platform. So my Raspberry Pi here has been coded with UWP, or has been installed with UWP, and then I've added some software that does some kind of cool stuff, I hope you think. Right here, this that we've been talking about that I've pointed out a few times, this is an accelerometer and gyroscope. So it makes sense that with an accelerometer and gyroscope, I can detect movement, right? So I can detect twisting movement. That's where the accelerometer comes in. So if you twist, I can detect it with gyroscopic speed, or if you move up and down, as you move up and down, I can tell if you're moving up and down. That's the acceleration. But acceleration also gives us gravity, and that's actually how it's measured, is gravity. So
there's a bit of math involved here. So you're doing a bit of heavy lifting here on the device.
Right. So what we end up getting is if I want to know the position in space of this device, I get gravity in 3 dimensions. So I can get gravity this way, gravity, this way, and gravity that way. So X, Y, and Z axes.
Well, so really how it's affecting each axis based on the orientation of the device.
Exactly.
Yeah.
So if I twist this a little bit, then I have a little bit of gravity affecting my X and a little bit of gravity affecting my Z.
Right, relative to the device.
Exactly.
Yes.
The Y-axis is still going this way, so it doesn't really care that I twisted it.
Right, unless our tables are not level.
Unless our tables
nothing's
are
rolling yet, so I think we're good. Yeah.
Exactly. And then the gyroscope can tell me when things are twisting around, and it can tell me how fast they're twisting. But it doesn't really tell me the position it ended at. So we get some pretty raw data.
So this is a really cool device. So what kind of things we do with a device like this?
Well, a lot of times it's used for, say, maybe working with your quadcopters. You want to know where your quadcopter is or if it's in a dangerous tilt.
Right, of course, the gyration, the rotation is very powerful there. And yes, using the acceleration, and much like you are, to detect orientation and then potentially correct that orientation.
Exactly. Or again, farm field equipment. We see IoT is used a lot in farm automation. So we see these things in your automated equipment that's going out on a field and doing things without much human involvement. And so it's really, really important to know if we've hit kind of a danger point in terms of tilt levels.
Right, we see if our tractor is tipping over. But yes, absolutely telemetry data, right? There's a lot of really amazing applications. It could be something, sports or automobiles. You're testing, G-forces in corners, and it's a really versatile little device. And what's amazing is these devices are fairly low cost considering the amount of power.
Yeah, I mean the entire setup that we have actually on the desk here is about $100, give or take. So about $100
not free,
US.
but it's again it's a much lower barrier to entry than it historically has been.
Right, and that's because I've got the whole hobbyist setup here too. So if you were actually going to productionize this, you'd obviously be able to bring those costs down incredibly.
Which I think actually brings us to another good point. So there's a wiring diagram, which hopefully you've seen, and the wiring diagram looks a lot simpler than what I see here on the table. So what's the extra bits and pieces that you have here?
So again, this ribbon really is just connecting me to this thing I call the breadboard here. So let me kind of...
Yeah, so often commonly known as a prototyping board.
We can see that, right? Right, the breadboard or the prototyping board. It allows those pins that are coming out of the Raspberry Pi to connect in. And then I have this little T-shaped thing that gives me some labels. And these, again, mapped to the pins that are not well labeled on my Raspberry Pi. So I can
that's something I love about this device. Right. We get the clear labeling. It makes it a lot easier.
So I can see here, for instance, that I'm having my positive battery go to the particular input on this breakout board. And then I can see, for instance, that pin 18, just a general purpose input output, just a pin, just a piece of data information is going to another location on my breakout board. And I can move that around and I can play with that, and it's really very easy with this setup here.
So good, great. So this build actually does match what we're seeing on the on our diagram.
It does. We just have a couple extra pieces.
Just a bit more wiring or plumbing, if you like. Yeah.
Exactly. Plumbing is the metaphor. It's a little bit more wiring is quite literal, right? So yeah, we've got the measurements going on, and of course we're running Windows on this device, and you notice that while there are a lot of wires going here, we actually have less wires than we have data points. I mentioned getting acceleration in X, Y, and Z, and we're getting gyroscope.
Because it's actually a 6-axis they call it, right?
Exactly. So I have many different data points that are coming in constantly. So the way this works is we actually do have a couple of these wires are using something called the I2C bus. This is just a data standard, and it's a pretty low-level data standard for sending bits, and it's a very, very common standard for setups like this.
Yeah, it's been around for a long time.
Absolutely, decades, I believe. So it's important to understand that this little tiny device then that we have right here, this guy has only a very few things on it. It has an accelerometer, it has a gyroscope, and then it has something to encode I2C data. So that is one of the very, very few little things on that. And so it encodes all the analog data coming in into that standard. Well, Windows has a library, fortunately, for consuming I2C data.
Fantastic. So I don't have to learn how to decode the bus.
A little bit, because it's a pretty low level, low level. But you're right.
But
you don't have to
get the data coming in.
Exactly. So
excellent.
Let's take a quick look at some code then.
Fantastic.
Where we're actually grabbing the data here. And again, we're using Windows libraries here. So we can see, for instance, my MPU 650. That's the name of that little breakout device that I have, that little gyroscope accelerometer. And then let's scroll down a little bit, and we'll see first I have some GPIO controller and GPIO pin. Now, the pin is called an interrupt pin. That's going to come in important here in a little while.
Now these seem similar to what we saw in Android things, but I noticed that the types are different.
Right, absolutely, because this is actually Windows classes right here, whereas what you were showing us were Xamarin bindings around Android classes. So they're similar because we're trying to do similar things, but they are different. So we have the GPIO controller. The GPIO pin is the interrupt pin.
And I see I2C device as well.
That's right. So I2C, remember, that's the bus. And so you can see it's built right in. It's a Windows type I2C device. So Windows is already set up and ready to go to read this information. So we've named it MPU 650 because that is our I2C device. So our Raspberry Pi is running the software, is running this code right here, and it's trying to talk to the little tiny board. But both of them are pretty small boards. So what happens then is, let's go find our initialization. So we're going to set things up with, first of all, our interrupt pin. Now the way this works is our interrupt pin is a single one of those wires. Just a single little one of those wires. And all that little device does, that little gyroscope accelerometer, is it's going to set that wire to have voltage. In other words, it's going to be a 1 instead of a 0. It has voltage on it. It has 3 volts on it then.
Right. It's a little like it's raising its hand and saying, hey.
You got it, exactly. It's saying, hey, 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 hey. And so it's interrupting, right? Great metaphor, because that's what it's doing. It's interrupting. It's saying, hey. And so when we get that hey, we actually have, so when interrupt pin's value changed, and in our case, that means when interrupt pin goes from low to high. We know that because we set it to low. We explicitly said, make that a 0, make that pin a 0. So now, when it changes, it means it's gone to a 1, which means, hey, the little device raised its hand. What it's doing is it raises its hand when it says there's some data available, there's something interesting going on. So, okay, we actually roll down to the interrupt class, and then here we can say, all right, we got an interrupt. That happened. Now that, so far, really isn't part of that I2C bus. However, we had the hand raised. Now we know that there is data, that hand raising is it telling us that there's data on the bus. So now we're going to go through and we're going to read the data. And at this point, it does, get a little bit in the weeds, right? We can see there's some pretty rough code going on here.
We're parsing this out, but of course the great thing is, well, one, I mean, we're able to leverage the open source community, but two, there is extensive documentation on these devices. And so we can read up on the specs of this particular device.
Absolutely, and it's not exactly light reading if you can't find anyone else who's done it before, but you absolutely can. And we actually did play with a couple other devices as well that didn't have extensive community and documentation. I can tell you it was a lot harder dealing with those than the ones we found that have a lot of community wrapped around them.
So we wanted to give you a simple example here today, but.
Yeah, exactly. So we've got this. It is interpreting code. It is coming in. We can see that it's Windows code using Windows classes, and even though it's a bit in the weeds, it's still Windows stuff and C# stuff.
It's C# and C# and .NET, and we're programmers, and we love this stuff, and we love a good challenge when it comes to coding.
Absolutely, absolutely. And so we can use this, and again, write more C# code, and we can use this to interpret that raw data. You can see I have that raw acceleration X, acceleration Y, some raw gyro data. And I can interpret these raw values and do a little bit of more math. And now this actually is not platform specific. So this is common. So gravities and rotation per second are common values. And that's what I have in my acceleration. That's what I've gotten platform specifically here, is I've gotten to that point of having that gravities and that rotation per second. So
you've got your data, and now you can do something with it.
And I've got my standard. So now I can break out of this platform-specific class. I've gotten it into a standard. And so now we're going to go into my shared code. And so here I have a simple rotation angles. And rotation angles has an update from gravity. Probably not quite accurately named because it's update from gravity and rotation. But we have update from gravity. And this then will do some math. It actually has some call-out methods. You can see there's a little bit of math here. It's not too bad in this class. So we call that, and we set our Euler angles. So that means our pitch, so pitch, roll, and yaw is basically the rotation in space of a plane.
Now this is really interesting because often we think of IoT devices as very low powered, and we might think of them sending data off to a bigger server to do this kind of processing. But what I'm seeing here is you're actually able to do the compute on the edge. You've got really this is the definition of intelligent edge.
Yeah, exactly. We're doing a ton of the processing right here. We're doing some of that processing right here to find out what the angles are, and so we actually know the position in space of this device right on the platform. We don't need to send the information up to be processed elsewhere. We've calculated it. We've figured it out. It's all C#, and so now we've got that information available. What's also really cool is not all IoT devices are headless. Some IoT devices actually can have a display. And so that's actually what you see behind me.
Absolutely. So a Raspberry Pi here actually has an HDMI output built in. That's standard hardware.
Yeah, and so we can have a display, and it seems that we do have a little bit of drift on my gyroscope, so it twisted all the way off screen while I've been talking.
But this is amazing. I'm seeing you move the device, and I'm seeing the picture on the screen respond.
Yeah, so let me make sure you guys can see me, and so I'm going to tip it, and it knows that I tipped it. And we have a little bit of drift just because I actually programmed this in another area with slightly different gravity. These things are sensitive. And I'm not a pro like the people who do these on actual Android devices and iOS devices and things like that.
But this is amazing. You're grabbing data, you're sending it to a tiny compute device, you're doing the calculation, and you're visualizing it in near real time. This is amazing.
There we go, spinning around. Yes, so we're of course just on a Windows platform, so we're able to actually get this going on here. And it is actually, by the way, 360 aware, so it realized I went all the way around here again, and you can see it coming in. So really cool stuff, and we can actually visualize it because it is a Windows platform with Windows video drivers and all that. But wait, there's more. It's actually Windows UWP, right?
Right.
Do you have any thoughts on some certain platform that might run on Windows UWP?
Well, absolutely. I love most of my UWP development these days is with Xamarin Forms because we love Xamarin because we're from XAMU. But yeah.
Yeah, it turns out that this is our entire UI here that actually has drifted off the screen again. There we go. Our entire UI is written in Xamarin Forms. So let's just quickly bring up our visualization here for Xamarin Forms. And by the way, all of this does run in a cross-platform way. So our entire visualization is cross-platform, and you can see on my screen we have many, many platforms. And on Android, we can even plug in some Android hardware and do exactly the same thing running locally like that. And so let me quickly just show you. Xamarin Forms UI is super simple. I have my grid. There's my box view right there. And then my box view is having its translation, rotation X, and rotation properties changed in response to the updates we got from that angles library. That's it. That's all of the Xamarin Forms code to make, admittedly, a very simple UI, but a UI that looks kind of neat and does some kind of neat stuff here.
Well, and I think it's mind-opening. It's eye-opening in that, okay, we're using Xamarin Forms. We've got applications we've already written in mobile. We're Xamarin developers. And we can actually run those applications on the IoT platform. We talked about the API surface. We see that there's enough compute to do intelligent compute. Output, this is a 1080p display. These are powerful little devices. And actually, when we were testing, we were running full applications that we wrote for mobile that would run on these devices.
That's right.
And there's something interesting here, too, is notice the framing of the window. So this is Windows, but we're not seeing the desktop environment. And it's really a good indication of IoT, again, in that they're meant to be typically single purpose. They have the ability to multitask, but you're going to have one primary app running on the device. And notice that there's no way to minimize or run side by side, right? It's just one application, so all the window dressings are all gone. But again, same applications running on mobile, pretty fantastic.
So wait, there is one more thing. So far we haven't really taken advantage of any of our Internet of Things being internet at all.
Absolutely right. We're just playing with the hardware.
We're just playing with the hardware and a little bit with visualization. I'd like to take advantage of the whole internet aspect. So let's actually send this data. We can take all this data we're pulling. Let's send it up to the cloud, to Azure, of course.
Of course.
We're gonna get that data up to Azure, and then we can process it with some client applications. So what I have running right here then is actually that same data. So you guys can't see everything I'm doing all at once because you can only see my screen, but I am moving the device around, and because both of these are internet connected devices, so I'm able to monitor from a remote application here what's going on with my device.
Really
and that's
powerful.
what I do. My laptop.
Right, you're not physically connected to this device. This is going through Azure.
Right. This is all coming through Azure. Everything you're seeing displaying on my device, on my laptop, is updating because it's getting the information about what my device is doing through Azure, through a cloud connection, actually on my phone, because I can't put this device on the corporate network here. So this is actually connected through an LTE connection, uploading all the data, all that real-time stream to the cloud, and then here on my laptop, we're pulling that data back down and displaying it in a real-time stream.
I love it, and probably more of a real-world application than using the, well, pretty fantastic infrastructure
Absolutely.
we have here.
Right,
Yeah,
we want to monitor what's going on with our devices remotely. That's a big part, was automation and monitoring. That is the things we're looking to accomplish with this stuff.
That was fantastic, Jason, and really inspiring.
Cool, isn't that fun?
It's so much fun.
A lot of fun.
So I think we're getting close to the end of our time here. So
I think we're right about there, yeah.
We'll wrap things up. So that was a ton of fun, and of course, all of the source code for all of these projects are available on GitHub, aka.ms netconfzamu. Of course, you want to learn more about Android things, head on over to developer.android.com, and if you want to get started with Windows IoT, developer.microsoft.com, and search for Windows IoT.
And if you just want to learn lots more in general, just tons more about cool Xamarin stuff you can do, university.xamarin.com, where I will excitedly tell you all about even more cool stuff.
Absolutely. I had a ton of fun on the session today. I hope you did as well.
Yeah.
Thank you so much for joining us.
We're not quite done with you yet, so join us for more .NET Conf session goodness. Bye for now.
Thank you very much.
Hi, welcome to Code Conversations. Today we're talking to Syed Abraham Hashimi. What are you going to show us today, Syed?
Hey, John. Today we're going to be talking about open source templates for .NET. And I've been working in the open source space for templates for several years now. Here's some of my kind of big efforts. We created Sidewaffle back in August 2013. And that was a way to create templates and share templates with people inside Visual Studio. And then ASP.NET Core popped up, and then we said, hey, we really need an experience, a cross-platform experience for creating these projects. So what we did there was basically there's a very popular Yeoman tool, and that's like the scaffolder for the web is what they call it. And in July 2014 was our kind of when we started that effort, and that's got 118,000 downloads, and these they've been pretty successful, these things. But with ASP.NET Core, it really kind of changed the world. For example, I work on the ASP.NET team, and we're shipping templates for these different tools and editors. So for example, we've got Visual Studio 2017. VS for Mac, we've got .NET New, and then we have YoASP.NET, which is our Yeoman generator. And each one of these has their own template format, and you'll create a template in a certain way, and then you'll share a template in a very specific way.
And they're not all keeping them in sync across all of the different lines.
Right, exactly. And let me tell you what, creating a template for Visual Studio and maintaining that template is incredibly difficult. You wouldn't imagine how difficult it is. Even with Sidewaffle, it's still very error prone. We heard feedback saying, hey, I want to be able to create templates across these different projects, and we also heard a lot of feedback saying it's too difficult to create templates, and it's too difficult to maintain templates. Maintenance is the real problem. So then we took a step back and we said, hey, we want to create a tool that's going to enable us to create templates for these different tools, and then also make it easier to create these templates. So comes in now the template engine, which is an open source project that we're working on. We've been working on it for probably about a year, actually. And the idea is that you'll create a single template, and then you'll ship that as a NuGet package. And then you'll be able to leverage that from .NET New, from Visual Studio for Mac, also YoASP.NET. And then you can add as many arrows as you need here. This is really just the starting point. And right now, we've plugged in the template engine into .NET New, and my team's working on plugging it into Visual Studio. And then hopefully at some point we'll then get the integration for VS for Mac, and community members are working on the YoASP.NET side of the house as well.
Okay.
So what I wanted to do today was basically show you how to create a template, and then how to use .NET New, and then how to exercise your template. And then depending on how much time we have, we'll see how much of that we can go through. basically.
Sounds great.
All right, cool. All right, so demo. So now let's go into using .NET New. Let me clear everything out. All right, so we don't have anything in this folder now. To start exploring .NET New, we can use the -H option here, and then that'll go ahead and give us some help. And you can see we've got a list option here. And then today it actually spits out the template list, but later on we'll change that to not spit out the template list by default.
Okay. So I can ask for the list if I need it, but it doesn't.
Yeah,
show it every
exactly. To ask for the list, you'll say .NET New -L, and then you'll see the template list.
time. Okay.
And then we also have template-specific help. So if I wanted to look at the MVC template, I can do .NET New MVC-H. And then here, now I can get into the template-specific parameters here. So I can see it's got an authentication option that defaults to none. It has a use local DB option, which defaults to false. So we use SQLite for cross-platform by default here. And then also a framework option here. All right, what I'm going to do is just go ahead and create a console app. And then I'm going to start building on top of that one. That's .NET New console. And then for the output, I want the output to go into a folder called c9.demo. And if you give it an output name, that's also the project name,
Oh, right. Okay.
which is basically the name of your project. And then if I were to look at the contents of this program.cs, we can see that my namespace has been changed to c9.demo here.
Right. Okay.
I can restore and run this, and it should print hello world. Let's take a look. All right. So that's going to restore. So now we've got our hello world here.
Nice.
So now I'm going to open this guy up in Visual Studio Code. So this is that same folder that I had opened up. Now I'm just going to go ahead and create a template out of this. Creating a template is pretty simple. And the model that we have is your template should always be runnable. So the crux of the problem of maintaining templates is the fact that you take an existing set of code and then you modify it to become your template.
You turn it into a template language.
Yeah, exactly,
that's
right.
not really the same thing, right?
So now you have two things to maintain. So basically the idea behind the template engine is your source is a template.
Okay.
So instead of going in and normally what I would do when I was creating a template, I'd go in and I would change this namespace to some type of token.
$, whatever.
Right, like $, root namespace or whatever it is, right? But instead of that, we kind of flipped that around. We said, hey, instead of modifying your source, you just add a file and you tell us what needs to be replaced.
Okay.
And then we'll process it. So that's the style here. So I'm going to add a new folder. It has to be called .template.config. And then I'm going to add a file into that. It's called template.json. And then I'm going to open up my other window here that has the actual content, and then we'll walk through this. There. All right, so I pasted in my my JSON from the from an existing template that I have, but it was created for this. Most of the fields are pretty self-explanatory, so I'll leave them as they are. There's two items I want to talk about here: the short name. So this is the name that users are going to use from the command line. So we saw .NET New MVC. That's a short name for something that's longer. You know, we have an identity field.
Okay.
And then the source name here is the important part. So c9.demo. What that means is that's the name of my project. And if there's a file that has that file name will get replaced with the user's project name
And the namespace.
Yeah, and wherever this particular string shows up, it will get replaced.
Okay.
So that's all I had to do. So now I'm going to go into .NET New and enable this template, and then we're going to exercise that template.
Okay.
All right, so I'm going to copy the path to this file. And then let me change my folders as well. Oops. So let me change my folder to go into C9. I'll show that there's nothing here. Okay, so the syntax is .NET New -- install folder path. And in the current release, we have a bug that it shouldn't end with /, so I'm going to remove that /. Okay, so I've installed it, and then in the template list, I can see I've got my C9 starter web. And the C9 starter web comes right from here, from the name.
Okay.
So now...
That's the full name.
That's the full name.
Yeah.
No, that's
Okay.
really that's the human-friendly name. The
Got
full
it.
name is the identity.
Got it.
Yeah,
Okay, makes
exactly
sense.
Right. Yep. So .NET New C9 Web. and then I'll say the output should be c9.demo. Okay, let's take a look. Cat program.cs, still the same stuff. So let me go through and I'll make a change to that file. Let's say the program.cs. Hello world from John and Syed. All right. Let me go back. I'm just going to make it into another folder here. Demo 2. To program.cs.
Ah, okay.
You notice I didn't even have to make that call for .NET New. I didn't have to do anything.
Install it again.
Yeah,
whatever.
exactly. You only need to call install if that metadata file changes.
Okay.
Otherwise, it's always looking at that folder, and every invocation for .NET New will get that folder basically.
Wow. Okay.
And there's a similar command for to install a NuGet package as well.
Okay.
All right. So that's.
And is that how then you've just created that template that you're using locally out of a folder? If you wanted to publish that, you publish that by creating a NuGet package?
That's right.
Then?
That's right.
Okay.
Yeah, you would publish that as a NuGet package, and at the end of the talk, I'll show you that we have several community members who've already created these NuGet packages, and they're sharing them on NuGet,
Nice.
and they have instructions for how to use it with .NET New.
Cool.
But yeah, exactly. That's the idea.
Okay.
Yep. All right. So now what I want to do is we've just created a console application.
If I fade back and forth, it gets us like halfway between.
Oh yeah, right. So now what I want to do is we've created a console application. I want to add a unit test to this.
Okay.
So let's see what that experience might look like. So let me switch back to my temp.NET New. All right, so let me go into the C9 demo. Let's see what we have here. Okay, so, all right, so let me go up one folder. I'm going to create a new test project,
Okay.
and that's .NET New XUnit. And I'll say the output should be c9.demo.test. Let's take a look at what we have. Now we have two projects here, right?
Demo and demo.test.
That's right. So now what I'm going to do is, earlier you saw me create this template config file and then a template.json file. And with Visual Studio, creating a single project template is one thing, and then creating a multi-project template
Where they're linked
is a
together.
totally different
Right.
thing. And it's
Nightmare.
it's like orders of magnitude more difficult. So what I'm going to do is take this template config file and move it up one level. Maybe I can't do that from there, actually. Yeah, here we go. All right, so I'm going to take this, actually just going to copy it, and then paste it here, and then delete this guy.
Okay.
All right, so I just moved it up a level, basically, right? So now what I'm going to do is, I made that call to .NET New install. So let me go back, and I'm going to make that call again, but now I'm just going to go up one folder. Because
Okay.
I just moved everything. I just moved that
It's kind
folder
of
up
solution
one level,
instead
basically,
of,
right?
Yeah. Okay.
Right.